In this unit, we are going to demonstrate how to set up a simple time domain simulation in INTERCONNECT and run it to get some basic results. We will start the simulation setup by placing a time-dependent source, a continuous wave CW laser, in the design window. In the property editor, we will keep the frequency at the default 193.1 terahertz and the power to the default 0 dBm, which corresponds to 1 milliwatt. Note that the output signal mode is set to sample, since it takes the value of the output signal mode of the root element by default. This means that the time domain simulation will use the sample mode approach. Next, we will add an amplitude modulator from the modulators folder of the element library. The amplitude modulator element modulates the amplitude of the optical signal at the input port based on the electrical signal applied at the modulation port. In the property editor, we will keep the modulation index to the default value of 1. To provide the modulating signal, we will add a non-return to zero electrical pulse generator. In the property editor window, keep the bias and amplitude to the default values. The modulation signal for the pulse generator will come from a pseudo-random bit sequence, or PRBS generator. Keep the bitrate to the default value of 25 gigabits per second. Connect the output of the CW laser to the input of the amplitude modulator, and the output of the pulse generator to the modulator input of the amplitude modulator. Connect the PRBS generator to the modulation port of the pulse generator. We will now add a straight waveguide to the circuit, followed by a PIN photodiode. We will connect the input of the straight waveguide to the output of the amplitude modulator. To keep things simple, we will keep the properties of the waveguide and the photodiode at their default values. Finally, we will place an eye diagram analyzer in the circuit. We will connect it to the photodiode output and the output of the electrical pulse generator. The simulation is now set up. We can run the time domain simulation by clicking on the Run button. Once the simulation finishes running, we can view the eye diagram from the analyzer.